Hello students, let us take one question, one numerical which involves reflected ray, refracted ray, which will involve an interface, which can be solved by different methods. First of all, let us understand the question. The question reads like this: a ray of light from a denser medium strikes a rarer medium at an angle of incidence I. Now, if I try to represent this first line of the numerical in the form of a diagram, then it will be something like this. This is the interface. Let us say this is interface, and here we are having denser medium. Let us say the refractive index is N2, and here we are having rarer medium. Let us say the refractive index is N1. Now what the question says, ray of light from denser medium and it strikes the, so the incident ray is this one. Now if we consider the normal, then normal to the interface is this, and it says that the angle at which it strikes is I. So this is the angle of incidence. Let us go to the second line. It says the reflected and the refracted rays make an angle of 90 degree with each other, which means they are perpendicular to each other. The angle of reflection and angle of refraction are R and R dash respectively. Find the critical angle. Find the critical angle for the interface. Well, students, we need to represent the reflected ray and refracted ray first before we start thinking how to solve. Now the ray of light is going from denser to rarer. Okay, just for the representation, just for the case of representation, see, this is the reflected light, and if I consider the refracted light, to be this. This is the reflected and this is the refracted. And this is the incident ray. Now, well, out here, one thing I have not considered is light rays traveling from denser medium to rarer medium, so it will bend away from the normal, so on and so forth. We are not required, we just need a ray diagram. That's why I have taken only the ray diagram. I have not considered that path. If the path was asked, then we would have drawn it according to that particular concept. See, it says that the angle of reflection is R and angle of refraction is R dash, and one more information, very crucial information, which is it says is these two are perpendicular to each other. That is the reflected ray, say, and the refracted ray make angle of 90 degree with each other. Now, if we apply Snell's law, from Snell's law, at A, what we can say, N2 sin I is equal to N1 sin R dash. So therefore, N2 by N1 is equal to sin of R dash by sin of I we get. This is what we are getting. Now, but what we can say, but R plus r dash will be 90 degree, because sum of three angles linear pair na, r plus 90 plus r dash is 180. Therefore, r plus r dash has to be 90. Also, I is equal to r. Why? Angle of incidence is equal to angle of reflection. So therefore, what we can say, I plus r dash is 90. So therefore, I is equal to 90 minus r dash. So use this information here. If I substitute that, what we get? N2 by N1 is equal to sin r dash upon sin I is what? 90 minus r dash. So that is sin of r dash by cos of r dash. This is N2 by N1. So what we get is, so therefore N2 by N1 comes out as tan of r dash. Now critical angle. Critical angle I equal to IC when r dash is 90. So therefore N2 sin of critical angle is equal to N1 and sin of 90. Therefore sin of critical angle is N1 by N2. So what we get from equation 1? Sin of critical angle is N2 by N1. Now what we are getting is sin of critical angle is, and from equation 1 what we can say, N1 by N2. N1 by N2 is 1 by tan of r dash. So therefore sin of critical angle is cot of r dash. So from this what you can write is, you can say critical angle is sin inverse of cot r dash, or sin of critical angle is equal to cot. We know this is 90 minus I, because I plus r dash we have seen it is 90. So we can say this is tan of I. So therefore critical angle is sin inverse of tan I. Students, see the choices, whether it is given in terms of r dash or in terms of I, trigonometry ratio will match like this. This is exactly how we can solve. This is one method. This I have written explicitly to explain you. It can be done very short. Now how to do it in a different other method is, see, when the condition is this, when the reflected light and the refracted light, they are perpendicular to each other, then this is the perfect situation for the application of what is called Brewester's law. So this is second method, alternative method. In Brewester's law what we have is N refractive index is equal to tan of I. This is Brewester's law. When the incident ray, so when the reflected light and refracted light are perpendicular to each other, then the refractive index of that particular medium is taken as tan I. Now critical angle, sin of critical angle is 1 by n. So therefore directly sin of critical angle is 1 by n is cot I. So therefore critical angle is sin inverse of cot r dash, or we can say So by using Brewster's law also we can find, care has to be taken that in which medium light is incident, that has to be considered when you are applying Brewster's law, because here the light is taken from rarer medium to denser medium when we are writing this value, this expression of n is tan I. While here in the first method we have considered the light ray traveling from denser to rarer. That is why there will be a change. So instead of writing sine critical angle as 1 by n, you will take it as n, because n1 and n2 will be inverted. Hence the sign of IC will be, you will write it as tan I only. Okay. So here what we will write, here sine of critical angle is n, therefore critical angle is sine inverse of tan I. That is exactly what we get. Once again I repeat, it is because light ray we are considering in case of Brewster's law, light traveling from rarer to denser, and in the present question it is given that the light is traveling from denser to rarer. That is the reason why we have this small change, because n1 by n2 is your 1 by n and n is what, n2 by n1. That is exactly what changes happen.